All right, we're off and rolling. Oh, let me turn this little light on so I can see my notes. All right, a lot of this stuff, like I told you yesterday, first day of school, that a lot of this is going to be repeat from Algebra 2. And some of this is repeat from even before Algebra 2, but that's all right. It'll get into it pretty quick here, so I got to change this, and I got to change this. All right, now let's see. Yes, it works. Thank goodness. All right, here we go. We're going to do a few definitions. All right, so just write that down. Oh, I got to get used to writing on this thing again. Definitions. There we go. The first one is called a relation. It's pretty general. Seems like this is writing differently than what it did last time. I don't know. I'll figure it out. Let's see. It's just a pairing of elements. I'm just going to write the word down. You write the definition down. I'll read it to you. It says a pairing of elements of one set with elements of a second set. Basically, a relation is an ordered pair. And you all know about ordered pairs. Done a lot of that in the past. So an ordered pair, just a quick example. Again, this isn't really pre-calculus stuff right here. It's just very general math stuff. There's an ordered pair. There's an ordered pair. You could even have a letter and a number being an ordered pair. That's what a relation is, okay? You've got it's a pairing of elements of one set with elements of another set. So this is paired with this, all right? And that's considered to be a relation. We're going to talk about something else that's not necessarily a relation. We're not going to talk about it right now. We'll talk about it a little bit later. But that's very, very general. The first, we'll get a little more specific. The first part of that ordered pair, that's our x, right? We always label it as our x, and then the second one is our y. But they got a fancy name. I probably will never refer to it as this, but it does have a fancy name. We'll write it down. It's called an abscissa, abscissa. So the x, I'll put a little x right there. That's the abscissa, and this is called the ordinate. It's not a coordinate, it's an ordinate. All right, and that is your y value of your ordered pair, okay? We talked about domain and range last year, didn't we? Yeah, so that's the next thing. All right. Man, I feel like a first grader trying to write for the first time on this thing. Because it's acting a little laggy. I don't know. Maybe there's a setting I could change. All right, so the domain are basically all the abscissas, or instead of writing that down, we're just going to say it's all the x values. Okay, so the domain are all the x values. And the range, obviously, I think it's obvious. What is it? All the what? All the y values. All right, so when we talk about the domain, we're talking about everything in the x direction. When we talk about the range, all right, so watch this. If we were to graph the x values, it would be all of these, wouldn't it? If we graph all the y values, it would be all of the vertical ones. Okay, so the domain goes horizontally and the range goes vertically. All right, so that's really important to understand. Again, today's just hitting the basics, really basic stuff. All right, a couple examples. It's kind of silly, but that's all right. We'll do it anyway. It's in the book. So I'm going to write some ordered pairs, some relations. And what we're going to do is find the domain, find the range. We're going to write it as a set. So if we write it as a set, what do you need to use, or what do you use to write as a set? What's the main thing that groups it all together? It's a brace. That's right. It's that squiggly looking thing. All right. So this is a brace. Okay. So if I do the domain, we'll put D for domain equals, put it in a brace because it's the set. It's the set of domains. So I've got these 4 ordered pairs. Which ones are the domains? It's all the x values, right? So it would be the 5, what? -2, 7, and 3. Pretty simple. Again, nothing earth-shattering here. Just trying to get some definitions down. Just make sure that we're right on the words. Okay? And so that would be the domain. What would be the range? It's just as easy, isn't it? Yep, it's 3. It's 3, what? 1, 5, and what else? Another 3. But when we have a set, we're not going to repeat it, okay? If you have a 3 here in the range and the 3 here, we're not going to put 2 3s here. Now, a lot of times, they want you to put this in order. So if you have a bunch of numbers in a set, a lot of times they want you to put it in order. So let's just put it in order. Again, nothing really tough. What would be first? -2, and then 3, and then 5, and then 7. Oops, that was terrible, Brace. And then obviously right here, if we wanted to put it in order, we would go 1, 3, and 5. Okay? Simple as that. Be nice if it was always this easy, wouldn't it? Yeah, not always going to be. I believe there's a, tell me what page it's on. You got your book out, right? Example 1, there's like a chart, a range chart. Is that correct? Page 5? Okay, so page 5, there's a chart, and it's I'm not going to, these numbers, there's a bunch of decimals and stuff. I think what we did right there is good enough to know what the domain and range is. But if you look at that chart, there's a relation, and they have all these points on that chart. Do you see it? Yeah. Do you see 28.6, 119.0? Yeah. There's a whole bunch of them. I think it's a waste of time for me to write them all out for you, but you see them in front of you in the book, and they just ask you to find the domain and range, all right? And they want you to put it in order as well. So the domain, I'll just read it to you. So the domain are all the x's in order from the smallest to the largest. So it would be 1.0, 4.9, 11.5, and so on. Everybody see that? It's probably written out right there in the book. I don't have the book open in front of me. I just have my notes, but that's what I have down. And the range would be all the y values. So the second, the ordinate, okay, it would be 4.1, 7.7, 17.5, and so on. They're just getting you to understand that when we do this domain and range, we're looking at graphs a lot of times, okay? And that's what they're trying to get you to do, is to see which part is the domain, which part is the range. Very, very easy. All right, so I could just talk through that first example. Let's do the second one. It's not much different. Example 2. Now this time, they're going to write it out kind of in words. They're not going to just give you a bunch of ordered pairs. They're going to give you a phrase, and what you need to do is find the domain and find the range of this phrase. So we want to find the domain of all the positive integers less than 6. So let's write that down. All the positive integers, I'll just put int, is that all right? All the positive integers less than 6. And that's our domain. So let's list all the positive integers less than 6, starting with the lowest one all the way to the highest one. So what's our lowest positive integer? It's a 1, that's correct. So 1. And then what's the next integer after that? 2, and then 3, and then 4, and then 5. Do we put a 6? No, because 6 is not less than 6, so that is our domain. Pretty easy, right? Oops. So that's the, oh, there we go. So that's the domain, all right? So they tell you the domain are all the positive integers less than 6, and then they also tell you the range. In words, they tell it to you in words. This is a little different. It says the relation or the range of the relation is 3 less 6. It doesn't say 3 less than 6. It says 3 less 6. Okay, I'm sorry, not 6. X, not 6. I said 6 on the other one. 3 less x. How would I write 3 less x? Well, x minus 3 would be 3 less than x. This says 3, what? Less, which is minus, and then what? X. So that's your range right there. What's the X? Well, these are all the X's, correct? So let's write down what our range is going to be. Right? 3 less X, or 3 minus X, or 3 minus 1. What's 3 minus 1? Right? I mean, I could write these out. We can do this in our head, can't we? 3 minus 1 is 2. 3 minus what? What's the next X? 2 is 1, right? So 3 minus 2 is 1. 3 minus 3 is 0. 3 minus 4 is negative 1. And then 3 minus 5 is negative 2. But let's put it in order from the smallest to the largest. How would we write it now? Yeah, we just flip it. We just go the other way. So it would be negative 2, negative 1, 0, 1, and 2. Everybody good with that? Yeah, that was pretty easy. So sometimes they'll do that. You might have some problems on there. They'll give it to you as a phrase in actual words, and you have to write out what the domain is, what the range is, and that kind of thing. What if you were to graph this relation? All right, so we're graphing this and we're graphing this on one graph. I'll tell you what, let's go up here. I think I have a graph there. Let's grab this thing. Let's go back down. There we go. And let's put it there. Let's make it a little bit bigger. There we go. All right, what if we were to graph basically this and this? Well, we have a relation, don't we? We have ordered pairs here. So we have one that matches up. Oh, you know what? I really shouldn't have put it in order from the smallest to the largest. If all you did was do this, but if I was going to match the domain up with the range, the 1 doesn't go with the negative 2, does it? Because 3 minus 1 is not negative 2. What does the 1 go with? Was it related to? It's related to the 2. So this is what we're going to graph. So really we're graphing, what, 5 ordered pairs, aren't we? If you want to write them out as the ordered pairs, let's just do it. So the 1 corresponds or goes with what? The 2. So we got a 1, 2. What else do we got? We got a 2, 1. We got 3, 0. We've got 4, negative 1. And then we've got what? 5, negative 2. So this is what we're graphing. All right, so let me do this in a different color so it pops a little bit. All right, so let's graph it. 1, 2. Where's 1, 2? Over 1, up 2. Everybody knows how to do that, right? Did a million of those things last year and in geometry. All right, 2, 1. So go over 2, up 1, right here. 3, 0, right there. 4, negative 1. 5, negative 2. Now, do we connect them? Make a nice straight line out of it? What does this say? All the what? All the positive integers, okay? And look at these. These are all integers. So if I connected them, I would also include all the stuff in between, wouldn't I? So do I connect them? No, because it says integers. That's the key. It says just the integers. So we do not connect them. We do not make a straight line out of it, because that would include all the numbers in between, right? The 1 and the 2 and the 2 and the 3. But we're not doing that. We're only including these particular numbers. If I remember right, it's been a year, well, a little less than a year, but I think on the quiz or a test there's one like that, and a lot of people made the mistake by connecting the dots. If it just says integers, then we're okay. What if it just said all the positive numbers? Then you could connect them, because that's everything in between. Everybody understand that? Okay, so if it says integers, you leave the dots and you don't connect them. And that's it. That would be your graph right there. Those dots would be your graph. Make sense? Yeah, good. All right, let's scooch down. Let's do a little bit more. All right, this one, they actually give you a graph and they ask you to tell what the domain is and what the range is. So this time they're going to give you a little graph. I'm not going to use the graph paper. I'll just use this. And I will make this red just to make it, again, pop just a little bit. And what if you had a line like that? And this went that way, and that went that way. And I ask you to find the domain and range of that graph. Domain and range. So what is the domain? The domain are all the what values?
X.
All the x values. So what x values are included on this line right here? Does it just go from like here to here? It goes infinity, right? It goes infinitely this way. So that means like from here all the way to there. All the x's are included to get to that point. Would you agree? Or to get to that line, I should say. So in order to get, like for instance, if I wanted to get to that line at that point right there, I could come over this x and I'd go over this y. Is there any x's that I could not hit before getting to that line? There's none. I mean, I can keep on going forever, couldn't I? Because what happens to this line? That keeps on going forever down. So I could keep on going forever to the left. I could keep on going forever to the right to get to that line. Agreed? What about up and down? It's the same thing, right? So I could keep, however far I go here, I could go up to there. If I go way over here, I could go up and eventually hit the line, couldn't I? All right? So I have no restrictions, do I? My domain keeps on going forever and ever. My range keeps on going forever and ever. And what we say, we just say all the real numbers. In my notes, I just wrote the words, all real numbers. You could do that, that's fine. There's a symbol for real numbers, and it's like an R with an extra little bar there, all right? So that means all the real numbers. So if you wanted to write all the real numbers, you could just do that fancy R, or you could just write the words, all real numbers. That'd be fine as well, okay? I think, did we learn that notation like from negative infinity to infinity? Did we ever do that? Okay, I think eventually we will. It's probably in here where we learn that. But you could also, I'll put a or, you could write it negative infinity and then comma, positive infinity. What does that mean? That means my domain goes all the way to the left as far as you can go and all the way to the right as far as you can go. That really means all the real numbers as well. All right, so that's a little sneak preview for you. Sometimes they'll ask you to write it. There's a fancy name for that notation, and I forget what it is off the top of my head. Haven't talked about it in months, so I forget what it is. But anyway, we'll eventually write it like that. Okay, so there will be a time where we'll do that. What about the range? Range is exactly the same thing. All right, so watch this. I'm just going to copy and paste it and then put it right here. All right, so the range is the same exact thing as the domain when you have it like that. So when you have a line like this, as long as it's not horizontal or vertical, if you have a line, the domain are all the real numbers, and the range is all the real numbers. What if you had a graph that looked like this? A little different. Okay. All right, and let's grab the red. So what if you had a graph like this and a graph like that? And we'll put arrows at the ends. Okay. So let's find the domain and range of this. What does the domain represent? All the what values? All the x values. Okay. So what I kind of like to do when I think of domain and range, are there any restrictions on the x? Like, can you go to a certain x value and it does not exist on that line? No, I can go anywhere to the left and eventually come up to that line. I could go anywhere to the right and eventually come up to that line. Would you agree? So what's the domain then? It's all the real numbers, okay? What about the range though? The range is different. Can I go all the way up from zero, from the x-axis? Could I go all the way up? Sure, because no matter where I go here, I could keep going up, up, up forever and ever and ever. But What can I not go? Where can I not go? I can't go below 0. That's right. So my range, we don't say what it cannot be, we say what it can be. So the range can only be the numbers from what to what?
0.
From 0 to infinity, right? Or you could say it a couple ways. Y, right? Because that's our y value, correct? And that's our x value. You could say y has to be greater than or what? Or equal, right? It could be equal because it hits right here at 0, equal to 0. Okay? Does that make sense? I also wrote down all the non-negative numbers, okay? Why didn't I just say all the positive numbers? Why didn't I just say the range could be all the positive numbers? Because 0 is not positive, right? Okay? 0 is not positive. But I could say this, or if I wanted to do this notation right here with the infinity stuff, how do you think I would do that? Where does it start? It starts at 0, and the range goes where? Up to positive infinity. That's right. So I could go from 0 to positive infinity. Does that make sense? Okay. This is the way I think the book wrote it. Did they put that in braces? But we can. I did in my notes, so that's good. Make sense? All right. I'll tell you what, I'm going to stop right there because we're going to talk about something else next. I'll give you a sneak preview. Did we do functions last year? Yeah, we did a lot of that. F of X and all that kind of stuff. Yeah, we did a ton of that. So we're just going to talk about that super quick. Remember I talked about a relation is very general. Well, a function is a little bit more specific, okay? We talked about it last year, but we'll hit it again. And that's it. So I'll tell you what, let me, I'm not officially giving you homework, but I'll tell you what the assignment is. So if you want to get started, get up to this point, find the problems that go to this point right here, and then you won't have to do so many tomorrow. We should be able to finish tomorrow. Yeah, we should. It's chapel scheduled tomorrow, and we're going to be outside. I don't know how long it's going to be, but whenever the next class is. So officially, the homework is going to be section 1.1, and it's pages 10 and 11. Now again, we haven't hit everything yet, but if there's a few in there that you can do, now there's a lot, but these are pretty easy. 17 to 49, odds. See, I gotcha. All right, so it's the odds. All right, so that's not so much. But I think it's a good idea to get started on it, right? Do as many as you can, and then I'm not collecting it tomorrow, but do as much as you can, and then I will eventually collect it. They should be. I believe they are, yes. The odd answers are, yeah. Yes, ma'am. Yeah, so let me give you did I talk about that yesterday? I can't remember. So here you go. Everybody look up here. Here's your paper, right? So I'm not going to take points off if you don't do this, but I prefer to have first and last name up here, okay? And then you could put the section number. So what I'm checking for is I'm checking for the section number. You can put page 10 and 11 if you want to, and if that helps you, it's perfectly fine. But if you don't have your first and last name, it's -1. If you don't have the section number, it's -1. Okay? If you rip it out of a spiral notebook and I got all these frillies on the end, it's -1. Okay? You got to do it in pencil. If it's not done in pencil, it's -1. All right? I've had people miss all 4 of those things, and you get 4 points off right off the bat before I even look to see if you did your homework, okay? So it's not hard to do. Just follow instructions, all right? Make sure it's clean edge, pencil, section number, first and last name. If you do that, you're almost guaranteed to get a 5 if you at least tried on the homework. You don't have to write what class. You can if you want, okay? But just make sure you have those things right there and you're good to go. Everybody good? All right, wait for the bell, and then we can go.